Hello and welcome to TidyX episode 88. Wow, 88 episodes. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, and TidyX is on Twitter, Tidy_explained. Tidy.explained@gmail will get you to our inbox. You can open up an issue on the GitHub repo. You can like and subscribe on YouTube. We always appreciate when you do that. Drop a comment there if you'd like. We'll get back to you there. If you like our work, want to support us with a beer or coffee, our Patreon website is also open for whatever you see fit. But otherwise, that's what we're at. Happy holidays to everyone.
Happy holidays.
However you celebrate, enjoy it. It'll be great.
Exactly.
And here we are, episode 88.
Episode 88. So last week we did day, I believe, six of Advent of Code. And so we thought then this week we'd solve the next problem, which we thought showed some ways that you can continue to use base R, but continue to solve these problems and also show some skills that you're going to use pretty regularly as a data scientist or anybody using R to solve data type problems. Patrick, do you have anything else to add as I go to share the screen?
No, I think just like you said, these little Advent of Code brain teasers have been a lot of fun, and a little bit, I guess, out of my wheelhouse. They're a little more kind of computer science based, but this is a nice one. I like number 7 here because it isn't overly complex, but it does go through some key concepts that you might use in your day-to-day, and we're going to talk through those right now.
Exactly. Yeah. So anyway, Advent of Code is a computer science puzzling problem where there's 25 different problems that are posted online at adventofcode.com by Eric Wastl. And so yeah, day 7 is kind of funny, but the general idea of this problem is you're in a submarine, you're trying to escape from a whale, and these crabs show up and they're little submarines. Apparently they're in submarines too, and are going to help you escape. But in order to help you escape, they can only move horizontally, and they all need to vertically line up in order to shoot a hole in the sea floor for you to escape the whale. You know, it's a story problem to help you figure out. So
yeah, and crab submarines aren't very efficient if they can only move horizontally. So.
Yes, exactly, and they only have a limited amount of fuel. So you need to determine the big problem is you're going to be given these crab positions. There's 1,000 different crab submarines. You need to get them to vertically line up. So what is the optimal position for them to line up using the least amount of fuel? And in the first problem, each unit of movement uses a single unit of fuel. All right, so let's hop over to our code here so we can explain it. Patrick, do you want to take us through?
Yep. First things first, we got to get our data in. So obviously the Advent of Code, once you sign up, provides you with the data that you'll need. So we're going to go to our Tidy Explained folder there, and we're going to grab the input file for the day 7 whales. It's a text file, so it's basically just going to bring in this text file. We scan it in, separate the values were comma separated. So it's basically a string of values with commas between them. And when we bring it into R, we get this X vector, this vector that we named X. It's 1,000 observations long, and you can see it's just a whole bunch of numbers randomly kind of sitting there. So what we're trying to do is we're trying to find the amount of movements that we can make that minimize our fuel expenditure. So when I looked at this and I looked at the example, I was like, oh, this looks like a Cartesian product. I need to basically identify the number of movements of each of those 1,000 values relative to every other potential value within the sequence. So I basically need a Cartesian product that shows me each of those 1,000 observations relative to every other observation. So the first thing I did was I started by finding the minimum value of our sequence and the maximum value. So it's going to go from, let's see, I think 0 is our min. Yep. And our max is 1935. Okay, perfect. So we got a min and a max. All right. So this was a 2-part problem. This is how I went about trying to solve part 1. The first thing I said was, okay, if I'm going to create a Cartesian product, I need to get a sequence of every possible observation between our minimum and our maximum. And so I create this sequence by saying from min x to max x, give me every value in 1-digit increments. And so that's what we get. Boom. Cool. All right. The next thing that I'm going to do here is I'm going to run this through in a for loop. And so in order to do that, I want to create a vector of NAs that is going to serve as a storage container. So basically right now, vector y has nothing in it. It's just a storage container for the outputs of my for loop here. So there's nothing in it.
And the reason you do this is because this is going to pre-allocate the memory for you. Because otherwise you could do a growing vector, which is concatenating it all together. But in R, that is rather inefficient. In most programming languages, that is rather inefficient. What you're going to want to do is predefine, hey, I'm going to need a vector that I know is going to be roughly this length.
Yep.
Let's take that memory now.
Yep.
Before I do this for loop, because that way it's just going to be more memory efficient.
Yeah. Good point there. Good add-on there. So now we're ready to basically solve this problem. And like I said, super easy. I solved it in one line of code, one for loop. I'm going to make a for loop that's basically going to run from every iteration I through the entire length of our vector, so all 1,000 values. And so within this for loop, I'm going to index each y output into our currently empty NA vector. So each index is going to drop the value into each one of those indexes as it goes through. Each of these observations that we're going to make is basically looking at the index value, looking at the value within our vector, and taking that value minus each value within the sequence of all of the values. We use the index there again to keep everything in order. We're going to do this as an absolute because if we left the negatives, they would cancel out and we'd essentially have most things minimized right around 0, which isn't helpful. So we're going to take the absolutes and we're going to sum those all together. So we're basically getting a sum of the absolute error, and we're going to store that in our y vector. And when we run this, it's going to run really fast.
So one quickly, just to make sure that people understand the logic here, is I is 1. Right, so this is our first index here. So we're going to pull out the xseq, which are the potential spots they might be. So this is going to be position 0. So pretend we told all the crab submarines line up at position 0. We're going to calculate how much gas they use by getting the difference between their current position, which is x, and this is the vector. Remember, x is the vector of all the different crab positions, and subtract 0 from them.
Yeah.
And so that is the distance they have to move in order to get to 0.
Correct. And then it's gonna loop through because our for loop says for I in 1 to length x sequence, it's gonna loop through. So the next iteration, I will become 2, and then I will become 3. And the whole time it's taking the absolute and summing these values. And once we run that for loop, which was incredibly fast, we get a new vector of 1,000 values, which are showing the absolute, the sum of the absolute difference.
1936 entries.
Oh, sorry, 1936. That's right, 1936 values. And so we can plot these and we can see what it looks like. And our goal is to identify the min value. So the bottom of that parabola, the bottom of that U is what we want to identify. So we could do this really easily by just saying, what's the minimum value and why? And that actually, if you took that number and you put it into the advent of code, you'd get a gold star. So spoiler alert, that's the answer. We can also look at the maximum value if we cared about that. And then I just threw in a few other ways of looking at the minimum value. So we could identify which index has the minimum value. So if we run this, it's going to be index number 334. So if we were to do y bracket 334, we'd find our value in that position.
Oh. Y 334.
There it is. We could also do the same thing by looking at but using which min, which is saying which is the minimum value of a vector. It takes a vector in that argument. And that's, again, 334. We've given that a name called minimum location. And we can also get the answer out of this by taking our absolute of our x values. So all of our x values in our sequence minus the minimum value at index 334 and sum them up. And there's the answer again. Spoiler alert, that's the answer. 328,262. Okay.
Cool.
Part two.
We've solved it. We now know to tell all our crab submarines, if you want to protect me from the whale that is hunting us, line up at position 334, and that'll use the least amount of fuel. You can now blast a hole into the seafloor, and I can escape. But part two. So part two is similar to part one. I'm just going to set the stage, and Patrick, I'll let you explain this again.
Okay.
But now in part two, you actually found out the crab don't use the submarines are actually really inefficient. They're not linear in that for 1 unit used of movement over, they're going to use 1 unit of gas. It's actually growing. So if it moves 1 unit over, it uses 1 unit of fuel stool, but for that second movement, so if it's moving from 1 to 2, that uses 2 units of gas for that second movement. And so it's actually an exponentially growing curve of fuel consumed for how far it goes, if that makes sense. So
if we had a vector that was like 1, 2, 3, and 4, right? So we have a vector that looks like that, and if this was to grow in the way that you're in the way that you're saying, right? It's going to go from 1 to 1 plus 1, right?
Yeah.
2. Yeah. So there you go.
So basically, if a crab had to move 4 units, this is the first move, this is the second move, third move, fourth move of gas that it used. Sorry, very clumsily explaining this problem, but it's just kind of a fun issue to solve, and I think we solved it in actually a kind of a pretty fun way.
Yeah. So the way that I thought about this one was we're going to create another vector of empty values because we're going to use that in our for loop. And when I looked at this, I was kind of like, well, we just really need like a lookup table. We basically need to say, okay, if Ellis said move 6 spots, how much fuel does that use? If Ellis said move 20 spots, how much fuel does that use? And if we look at the values of that 1, 2, 3, and 4, what we're really dealing with here is a cumulative sum problem, right? So if we were to do cum sum over v, over vector v, that's what we're trying to get, right? So basically the numbers compounding on each other. Now, if we did this, we need to ensure that our vector of the X sequence length, remember that's the length from 0 to 1936. We need to ensure that our vector starts at 1 unit of gas because you don't burn 0 units of gas. So we add a 1 to our cumulative sum function, and we get this new vector. So boom. And so if we look at this, we've got a cool vector.
Correctly.
Yeah. So for example, if you were to do gas used vector and we wanted, to make 100 moves, right? How much fuel would we expect to burn? 5,050 units. Okay. The rest of the problem is literally the exact same thing, just using our lookup table. So now we do the same for loop for I in 1 to length X sequence. We're still using the same sequence of values. We're going to assign the outcomes to our new Y2 vector, which is currently empty. And we're going to take the sum of the absolute differences. The only kicker here is that we have to make sure we're using the gas used vector index. So basically, when we take the sum of the absolute of the differences, that's going to give us an index that we then want to be able to pull out of that gas used vector, and we're going to store that in the Y2 vector.
And one other thing that I want to bring up too is you can. The reason we're able to do this is because we're able to identify multiple indexes to be pulling out of the gas used vector. And so I just put down a couple examples down here. So say this returned saying, okay, so we need in order for crab 1 to move to this location, it's going to use its 1 distance. The second crab now also only has to move 1 unit over. The third crab has to move 5 units over.
Yeah.
The fourth crab has to move 6 units over. We're able to pass those indexes into gas use vector and pull all of those out of the index.
Yeah.
And
then sum them.
And then sum it together. And so it's kind of like vectorization. It really actually isn't vectorization. It is, you're able to pass multiple indexes into a vector to grab all of those indexes, and it's going to return the values in the order of the indexes that you put in.
Yep.
So
cool.
Just wanted to point that out so we can run that.
We run that, and we get a new vector called Y2. It has a whole bunch of different values. Now you can see they're substantially larger than before. Again, we want to find the value that is at the minimum of this U-shaped curve. And if we do this right there, spoiler alert, that is going to be the gold star answer. Yeah, and then we can look at this the same ways. We can find the max value. We can find the minimum index value. We can assign that minimum index value to a new vector or object, and then we can also subtract and get the same value. Yeah, there it is, right at the bottom there. Oh,
yeah, that one right
perfect.
there.
And that is how you solve Advent of Code Day 7 if you're ever on the crab boat and need to escape the whale.
There you go. So if you like what we're doing here, you want us to continue, let us know. If you have any topics of things that you'd like to see us solve and explain how you write the code and explain what's going on with the code, really under the hood, let us know. We really appreciate hearing from all you.
Or if you have some New Year's goals of things that you want to learn and you think there might be something we could help with, we can make an episode about it.
Yeah. Or a series of episodes.
We
like the series of episodes.
Yeah, indeed.
Mm-hmm. So with that, I guess we're going to call it here. Thank you all so much for joining us for the last year and a half, almost 2 years of TidyX. Happy holidays. If you appreciate what we're doing here, please like and subscribe. Leave a comment down below. Love hearing from you all. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. I am on Twitter at OSPPatrick, and at Tidy_explained is where we both are on Twitter. Tidy.explained@gmail.com is where you can email us. Open up an issue on the GitHub repo if you'd like, or if you're comfortable, like and subscribe on that YouTube page and drop us a comment. We really appreciate that.
Mm-hmm. And if you want to become a patron on Patreon, go to patreon.com/tidy_explained, and you can sign up to be a patron. Thank you all so much, and keep on exploring your world.